Hello, everyone, and welcome back to the second session on microservices. In this session, now we'll continue with our discussion of the comparison of various architectures that we have seen so far. So, as we saw, there are three types of architectures. One was tightly coupled, the second was loosely coupled, and third was decoupled. So we also saw how they are architected and what are the various parameters by which we design them. So now let's try to understand what are how they compare with one another. So the first attribute which we'll use for comparison is the implementation and maintenance. That is one of the key parameters which we use to evaluate any architecture. That is how easy it is for us to kind of implement that architecture and also maintain it over the time. So as we saw that for monolithic, the implementation and maintenance is easiest among the others architecture. Why that is the case? Because since we are keeping all the presentation layer logic, the application service layer logic, data access layer logic, everything as in one code base and also deploying it to a single server, it kind of becomes easy for us to maintain that application, also develop it easily. But if you take any architecture which is loosely coupled like SOA or event driven architecture, the implementation and the maintenance becomes partially complex because now we have to deal with developing independent systems which are deployed on different servers, and also we have to also find a way to interface between each other. So that is why the implementation for loosely coupled server is partially complex. And finally, if you take the decoupled architecture like microservices, the implementation and maintenance is complex, and all these are kind of relative when I say the easiest and when I say complex. So these are just relative to one another. So if I have to just rate implementation and maintenance between all the three architecture, then I would say the microservice architecture is most complex to implement and monolithic architecture is the easiest to implement, right? And why we say it is complex for microservice architecture, that is because as we saw that we have to develop independent services and a database for each of the services which will be again independently deployed on different servers. So in this case, the kind of code and overhead which we have to write and manage is large. That is why the implementation and maintenance for microservices is complex. The next attribute which we will be used for comparing is scalability. So what we mean by scalability is, so I'll give you a very simple example. So assume that you are developing an application for booking a cab, okay? So you just imagine that you are a startup who just invented a cab booking application. So as you know, when you just initially develop your application, there won't be many users, right? Probably it will be just 10 users or 100 users. But just assume that you have started to grow like Uber. So over the time you have really garnered tens and thousands of customers. So what happens is over the time, as your application popularity grows, even the load of your server on your server it goes up, right? So today there will be 10 users accessing the application, tomorrow there will be 100, then day after there will be 1000, so on and so forth. So when we say scalability, all it means is does our application grows over the time as the load on the server increases, okay? So in case of monolithic application, which is in case of the tightly coupled architectures, it is not easily scalable. Why it is not easily scalable is, since we are going to kind of just deploy all the application in a single server. So what happens is whenever you have to scale your application or your application requirement increases, either you have to make changes and redeploy all your application in the server, or you have to kind of add an extra server manually and then deploy all this application into it. So the kind of the work which you have to do to make it scalable is not easy. Okay, and mostly monolithic applications are also on-premise server. What do you mean by on-premises? Since you are going to have a server physically in your environment where you're going to deploy it, so this maintenance of server and scaling of the server is not quite an easy job because you cannot just add another server on the go without first having them in your environment. For loosely coupled architectures like SOA, the scalability is partially complex. Why? Because since it is loosely coupled, the components can be independently scaled, but still there are certain limitations which has to be taken into consideration. They are just not infinitely scalable. You also have other complex parameters in place because they are going to be interconnected using service bus, and there could be other server related restrictions as well. But if you take decoupled architecture like microservices, scalability can be easily achieved. Why that is the case? Because since your servers are independently deployed in the cloud. And as you people may know, in the cloud, it is very easy to spin up a new instance and create a new instance of your server just on the go, right? You don't really need to have all this overhead of manually provisioning a server, then starting the server, deploying your application and all that. So when you use any of these cloud providers like AWS, Google, or Azure, all of them provide this auto scaling option. So once you deploy your microservice application, it is very easy for us to kind of scale our application on the go. So what happens is tomorrow, if you say develop a app which is a Uber competitor, and over the time your application popularity increases, so you don't really need to sweat a lot in order to make your application handle the large load. If you enable auto scaling and other such features which are available with the cloud vendors, your application can easily grow over the time. The next important attribute for our application is testability. So what we mean by testability is how easy is it for us to test our application, right? For Monolithic, the testability is really not scalable or not easy. Why that is the case? Because since everything is kind of tightly coupled, it is not easy for us to independently kind of test each and every part of the application independent of each other. So either you have to write a test case which will test end-to-end scenarios, but there you cannot test a few scenarios where you just want to slice and dice your application and test just a few functionality of it. So say for example, if I develop a application for IRCTC, right? For example, and I just wanted to test the part where I want to test if the logic for Tatkal is working fine. If it is a monolithic application, I have to write the test right from the user clicks on the booking reservation system right till the point that the ticket is generated, because my entire code is so tightly coupled, I cannot just take out a single functionality and test it independently, right? But whereas in case of loosely coupled architectures like SOA, testing is partially doable, or I would say we can achieve a good sense of test cases. Why that is the case? Because since we are going to develop loosely coupled components, it becomes easy for us to kind of isolate the few components and test them independent of the other components. But whereas in microservices, since they are totally independent of each other, the testing can be easily achieved, and you can easily slice and dice your application to write your test cases accordingly. And the last parameter which we are going to discuss today for this comparison is fit for agile development. So first we should understand what is agile development, right? So some of you are not familiar with this agile development concept. So in the last, I would say 10-15 years, there is this concept of agile development, which is now the industry standard for developing any application. So earlier what used to happen is we used to follow the waterfall software development lifecycle, wherein each phase of your application had a definite step, and we used to develop and complete the application in its whole. So say for example, if I had to write an application for Uber, right? It was not I could just write a simple prototype this week, test it, and then ask my user how it is, and then again keep on improving it. How the Uber used to be developed in those days? What I mean to say is before Agile came into picture is, first you used to take the requirement from the end user, from the business users, then you kind of analyze those requirement, then you kind of wrote the code for that particular requirement, then you tested it, then it went for user acceptance testing, and after all the approvals was received, and then finally was the software made available to the end user, right? So this used to be really taking a lot of time, sometimes even years, and it was really cumbersome process. So that's why what happened is now it has been replaced with agile development. So what agile methodology says is, instead of waiting for quite a lot of time and doing a lot of redundant work on that aspect, it is better that you just keep on iterating incrementally and develop value adds just over the go. So say for example, if I'm going to develop a Uber app, maybe in the next 1 month I will develop a simple app which is just going to let me book a cab from say point A to point B. That's it. No other features enabled. So maybe in the next iteration of that, probably I would even get a feature where I could schedule a ride maybe some days or hours in advance. Maybe in the third iteration or in the third release, I would have a feature where maybe I could book for my friend or relative. Or maybe, and in the next iteration, maybe I could have something like a profile where I could save my card. You're getting my point, right? So the whole point is, if the same was done in waterfall, what used to happen is all these features usually used to be given or released in one single build, and that used to really take a lot of time, because developing all this together used to really be a time consuming process. But in Agile, since we have kind of made things loosely coupled, and the focus is more on the value adds or the end user, we are doing incremental deliveries, right? So why we were talking about Agile is, since Agile is, I said, the de facto standard for the today's software development lifecycle, tightly coupled or architecture like Monolithic are not easily fit for Agile development, because as I said, Monolithic architecture are really a good fit for the water cycle kind of life cycle of development, because there you really developed a lot, the entire application in one go and deployed. And if you take loosely coupled architectures like SOA, they are partially a fit for Agile development. Why I say partially? Because since they have components which can be independently developed, they can be developed by various teams in parallel. But there are again a few bits and pieces which needs to be which has some dependencies with all these components. As I said, you have the service bus and other infrastructure related setup. So that's why it's not a full fit for Agile development. Whereas if you take any decoupled architecture like microservices, it is a perfect fit for Agile. And why that is the case? Because each services, since they are independent and you can just develop them independently, you can have multiple teams which can work in parallel. So for the same Uber application, what I can do is one team can work on the feature where they can book the cab, the other team can book on a feature where they can book the cab in advance, the third team can work on a feature where maybe they can book the cab for friends or relatives, the fourth team can work on profile, so on and so forth. So that is why decoupled architecture is the best fit for Agile development. So moving ahead, now that we have understood what are the various architectures available, so far whatever architectures we saw, these were just to ensure that you have a broad idea of what we are doing. So before just jumping into microservices, it is also important for you to know what are the other alternatives available in industry today and why we are learning microservice. So I hope by now you would have understood that microservices has a lot of plus points compared to other architectures, mainly in terms of what we saw right now, right? It is easy to implement. I won't say easy to implement. It is easy to scale, easy to test. And also it's very a perfect fit for Agile development. We also saw the challenge that it is a bit complex to implement and maintain, but in this course we'll also see how we can mitigate that to a certain extent, right? So without wasting much time, let's now jump into the introduction of microservices. I'll just dive a little deeper into microservice architecture and understand what it's all about. So microservice is a pattern in which the application with several independent services is composed. So as you can see on the picture on the right hand side, so as we have a user interface which will be talking with the API gateway. API gateway is nothing but you can just say it is a component which will just listen to the request which is coming from the UI and then decide to which microservice this request has to be routed to. Okay, so what happens is when you develop an enterprise application, normally the user interface will not directly tell the server which microservice or which server this request has to go. All they will have is they will have a certain request in a format and they will have certain payload attached to it. Then your API gateway will dynamically decide then which request, which microservice server will this request go to. Does it goes to the HR microservice or the I'm just giving a simple example from my enterprise. So does it go to HR and microservice or does it go to the operation microservice, does it go to the sales microservice, so on and so forth. So microservice is just kind of the API gateway is nothing but just kind of an interface which sits between the end client and the microservices. And each of these services that you see below, right, microservice 1, 2, 3 and all that. So each of these service specializes in performing one particular task independent of other service. Okay, so say for example, let's take an example of bank which we are going to develop in this course. So if I take a bank and bank has many departments, as you know. So in that, if I just take the example of say loan department. So one specific function of loan department is to give loans, right? So I will have a API or I will have a microservice which is designed only to grant loans. Okay, so that API's only function is to ensure that based on the request received, I will either approve a loan or give a loan or I will reject that loan. Right, I won't do any other additional task with that. For example, I won't give you the balance or I won't tell you what is the status of your account and all. For that, I'll have to develop a different microservice. So the moral of the story is each microservice will only specialize in performing a particular task and that has to be independent of other service. That is a key point to be noted over here. And since microservice applications are composed of several independent services, they are also easy to develop, test and deploy independent of other services. Okay, so don't get confused confused. In the earlier comparison, we said microservices are generally little complex to develop and maintain, but here we are saying they're easy to develop, test, and deploy. So let's understand what it means over here. So as I said, today we have Agile development methodology, right, where the focus is on creating small features incrementally over the time and develop the entire application. So what happens in the enterprises, normally for a particular application, there will be many teams which will be working, right? And since each of these services are independent, it is easy for us to kind of split each of these services into features and give it to them independent teams. So say for example, if I have to develop Uber application or IRCTC application, so I can have say maybe 5 teams. One team can just focus on the train ticket reservation part. The second team can just focus only on the food ordering part. The third team can maybe just focus on the part where you can also allow the user to book flight tickets, so on and so forth. So what happens is all these 3 teams don't have to depend on each other. They can just simply start the development, testing, and deployment activities independent of each other. And finally, when all of them are complete, I can just integrate all of these into my core application and we are good to go. So that's why we say that, since they are independent services, they are easy to develop, deploy, and test. Okay, and why they are also easy to test? Because since they are independent, every team can write their own test cases. They don't really need to depend on other team to write their test cases. And also microservices are distributed and decoupled from one another, so they can be scaled very easily. So what is the meaning of that is, since we are kind of decoupling each service from one another. See, this is a term which we are repeating again and again, right? We are saying that it is an independent service, it is decoupled service. So what is the benefit of that is they can be scaled very easily. Okay, so I'll give you an example of this. So just assume that we have developed maybe we have developed an e-commerce website. Okay, so maybe just take the example of Amazon or Flipkart. So what happens is Amazon or Flipkart are really made of tons of microservices, right? So assume that some festive season comes in, maybe Diwali, Holi, Eid, whatever. So suddenly there is a spike in the people searching for a particular product. Okay, so what happens is we want to ensure that our application is able to handle that search query faster. So maybe the people are loading your application and searching for say maybe a kurta or pajama, whatever. So your microservice which is concerned with that particular search feature, right, which is searching for the user query, should be scalable at that particular period of time. So in case of microservice, it is quite easy to do that, because since our services are independent, we can spin multiple versions of multiple deployments of that particular service into other services. As I said, cloud vendors support this auto scaling feature, so we don't really have to sweat a lot and write a tons of code or do a lot of configuration in order to achieve that. Similarly, if we have to develop cloud native applications, microservice architecture is one of the necessary ingredient. Okay, so what is the meaning of cloud native application? Don't worry, we have a in-depth discussion about this in the next week session. But for now, just understand that cloud native applications, as the name implies, are the applications which are written for cloud. Okay, so what is cloud? If you people are not aware, we basically have there are 3 famous vendors of cloud. One is Azure, Google, and AWS, Amazon Web Service. So what cloud means is, earlier whenever you used to write applications, we used to kind of have the servers for that particular applications installed or bought out, and we used to maintain our own server farms, right? The enterprise really used to maintain their own server farms, but over the time they realized it is really a waste of effort and energy and all that thing to have all that ourselves and maintain it. Because say for example, if you take a company like Uber, right, their core strength or their core revenue is from writing the code which helps you to get the cab and do all that stuff. But if you're going to spend a lot of energy just to maintain the server, deploy the server, monitor the server, they really are spending part of the energy which could be used productively in some other part of the application. So that is why this cloud came into picture, wherein we are outsourcing the infrastructure part of our application to some third-party vendor like Microsoft, Google, or Amazon, wherein they have the infrastructure upon which we can deploy our application. That is just a very simple definition of cloud. Cloud also has other advanced features wherein you can also have certain services also has certain services outsourced. So say for example, you want to do SMS or you want to send automated emails. So even those kind of services, instead of writing your own application, you can simply subscribe to the cloud vendors and get that service provided from them. Okay. So, and also another thing to notice, the industry is now slowly moving into the cloud native or cloud first application. So wherein any application that you develop has to support cloud as well. And in order to develop cloud native application, microservice architecture is one of the essential ingredient. Why? Because since microservice develops like kind of independent services, it is one of the necessary ingredient in order to ensure that it is able to run in the cloud and able to scale fast. And with this, we have come to the end of this session. In the next session, we will now next understand what is the Java ecosystem for microservices. Thank you.